In the world of e-commerce, every millisecond of latency matters. Creating a fast, reliable performance solution for end users can help drive sales. Fortunately, it's easier than ever to do this. In this tutorial, we are going to learn how to create a distributed REST API for an e-commerce store using Cloudflare, Workers, and Turso. The prerequisites for creating this project are Node.js and NPM, the Turso CLI, and the Cloudflare account. If you haven't installed the prerequisites, please pause this video, go ahead and do that. The links to these three can be found below this video. To create a new Cloudflare Worker project, run the command npm create Cloudflare. Respond to the resulting prompted questions as follows. For the project's name, we'll use REST API. We'll also want our initial project to be a simple Hello World script. I'll opt to use TypeScript for this project. You can opt out of it if you favor plain JavaScript. For this simple project, we'll not be setting up JIT. We'll then wait for the project's dependencies to be installed. We'll not opt for deployment of the project at this step since we want to do this at the end of this tutorial. Next, open the project in your editor of choice, and in my case, I'll be using VS Code. On the left, you should expect to see the project directory structure shown here. Most of our code will be going into the worker TypeScript file. Delete the commented out code within this file since we have no use for it. Also, delete the commented out bindings inside the worker configuration file. If it's the first time you're working with Cloudflare projects, you'll need to authorize the Worker CLI tool to use your Cloudflare account. To do so, open the terminal and run npx wrangler login. A new tab listing all the permissions to be granted will be opened on your browser. Click Allow to proceed. You should then see a successful message both on the browser and on your terminal. Next, we'll be creating a Turso database. After having installed the Turso CLI, you'll need to authorize it to use your GitHub account before starting to create and manage databases. To do that, run the command turso auth login. This will open a new browser tab asking you to authenticate via GitHub. If you're running this for the first time, you'll need to give Turso CLI permissions to use your account. Grant Turso the permissions needed to proceed. After authentication, run the TursoDB create command, passing the database name, in this case REST API, to create a new database named REST API. We'll need the database URL and authentication token to be able to make transactions with the created database from within our project. To get the database URL, run the command tursodb show, passing the URL flag and the name of the created database. For the authentication token, run tursodb tokens create, passing the name of the database. As you can see, we have the URL to the database and its authentication token. To use the database URL within our Workers project, add a new vars section inside the Workers configuration file and add a new environment variable key tursodb URL. Then we can copy this value and paste it over here. Since the authentication token is a sensitive variable, we'll add it as a Worker secret environment variable by using the wrangler secret put command. When prompted for the secret value, paste the token from the terminal output. For local development, the wrangler tool will obtain secret environment variables from a .env.vars file. Create this file and add the secret key and value. Next, we'll add the environment variable keys to the Worker's environment interface inside the Worker file. At this point, when we fire a local server by running npm run start in a new terminal, we should see the text hello world. This is because that is what is being returned from our fetch function. Let's change this to have respective JSON responses as we normally do with REST APIs. Currently, all the requests to our API server are being responded to with a hello world message since that's what the fetch function is returning inside our Worker file. Let's streamline API endpoints by using a router. We'll be using a small JavaScript microrouter called itrouter. Let's open a new terminal window and install itrouter by running npm install itrouter. Let's also add the router's type to our worker file environment interface. Next, let's create a function that initiates and returns the router type. In it, let's add a casual router get method that will respond to all requests with the text "Hi tutorial." We can then update the fetch function to use our router to handle incoming requests. Now, when we visit the API URL, we should see a JSON response with the text "Hi tutorial." Before adding endpoints to our API, let's first define its data models, generate their schemas, and migrate them to our database. We are going to do this with the help of Drizzle. To use Drizzle as the ORM of our Turso database, we'll first need to install the following dependencies. The Drizzle ORM package is used to model data schema, migrate them, connect to our database, and build queries, while the Drizzle Kit package is a CLI tool used to generate migration files. We'll use the TSX module to execute the TypeScript code, and lastly, the .env package will be used to get environment variables from .env files. We'll be adding all our Drizzle code inside the Drizzle directory within our project, so let's create that. For the database schema, we'll add a schema TypeScript file inside this directory, and we'll be pasting Drizzle schema from a GitHub repository whose link is provided below this video. In this Drizzle schema, you can see that we have a categories table and a marks table being created. Let's follow suit by creating a generate package JSON script that will handle the schema generation task. In this script, we are using the Drizzle CLI to generate SQL migrations, passing the Drizzle migrations directory as the output directory for the generated files. We'll be generating these migrations from the schema provided inside the schema TypeScript file. We can then run npm run generate to generate the migrations based on our Drizzle schema. Open the Drizzle migrations directory to see the migrations file. To migrate the generated schema to our Turso database, we'll first need to add migrations code. We'll create a migrate TypeScript file, insert the Drizzle directory, and paste the migrations code from the same GitHub repository whose link is listed below this video. In the migration file, we are passing the directory to our generated migrations as an argument so that the Drizzle libsql migrator knows the location where to find the migrations. Since the migration process is done locally, this code will not be able to access the database credentials passed within our Cloudflare worker. Hence, we'll need to add the credentials to our .env files for this code to run successfully. As you can see, we are consuming the environment variables within this migration code as we normally do within Node.js. Create a .env file and paste the two environment variables used within our project. Let's create another package.json script to handle the migration task too. We can then perform database migrations by running npm run migrate. To verify that the tables were added to our database, run the following Turso shell command. This will confirm that the two tables, categories, and marks were added to our database. Before proceeding to create the API endpoints, let's first seed some data to our database. I'll paste the database seeding code from the linked GitHub repository to a newly created seed TypeScript file inside the Drizzle directory. As you can see, this seeding code depends on the UUID and lorem ipsum packages, so let's install those. Let's add another package.json script that will handle the database seeding task. Let's make the DB instance accessible to our seeding code by exporting it from inside our migrate file. Let's remove this unneeded dependency. After that, we can run npm run seed to seed some data to our database. Let's run another TursoDB shell command to verify that some data was added to our database. As you can see, 12 records have been added to our marks table. For our API to be functional, we'll need for it to respond to HTTP requests with expected JSON data depending on the nature of requests. Let's create a database client by building a function that returns a LibSQL client wrapped with Turso as the query builder inside the worker file. First, get the database URL and make sure that it's not undefined. We'll throw an error detailing that otherwise. We do the same for the authentication token. If both are valid, we'll return a new Turso instance. In our database client builder, we are first checking whether the database credentials have been provided and returning a Turso instance. Otherwise, we throw an error. Let's then initiate a database client inside the router function so that we can be able to query the data from within our router methods. Now we can add some few endpoints that receive requests and respond with the expected JSON data. Let's first create a get endpoint that returns all the marks within our database. To do that, we are going to move the catch-all router methods to the end of the requests. Then we are going to add a marks endpoint. Returning a JSON response containing all the marks collected from the database. On the browser, we can visit this endpoint to see the return results. As you can see, all our marks within our database are being returned. Let's create another endpoint that returns mark details based on the ID passed as a route parameter. Returning a JSON response containing the mark obtained. On the browser, we can visit this endpoint by taking one of the mark IDs and updating the endpoint by passing the ID. This will return the details of the specific mark. For more endpoints, check out the blog post and GitHub repository linked below this video. The final step of this tutorial is the deployment of our REST API to Cloudflare. Luckily, this was already configured for us as we were scaffolding the new workers project. You can see this deploy script by opening the package.json file. Update this script to reflect the latest changes to the Wrangler CLI. Then, to deploy this project, we simply run npm run deploy. After successful deployment, try visiting the live REST API URL and test the added endpoints. Let's test the second endpoint for the individual mark. Since our API fetches data from a database, and up to this point our database is positioned at a central location, JNB, the users trying to access it from other locations will not be seeing the benefits of the Cloudflare Edge deployment. To rectify this, we'll also need to place the database being consumed by the worker near the REST API consumers by replicating the Turso database to those locations. To see a list of database deployment locations that are currently supported by Turso, run the dblocations command. Here is the full list of all the locations that you can deploy or replicate a Turso database. For example, if we have determined that our REST API's consumers are based in California and England, we can create replicas for Turso in those two locations by running tursodb replicate REST API and passing the location ID, LHR for London, and running the same command and passing SJC for San Jose in California. This will highly reduce the latency experienced by users both in England and California. This is the end of this tutorial. More information regarding this tutorial and the GitHub code use can be found in the links below this video. See you in the next one.